Chapter 1 Third, MI and Binomial Theorem, Part 1. In this video, I would like to discuss how to simplify some third. What is the meaning of a third? Do you remember? In junior form, we have already discussed the radical sign. That means this sign. This sign is also called a third. And example 1.1 is some typical example in your junior form questions. How to rationalize the denominator. If I have a fraction like this, you need to remember in the fractions, if the denominator is a irrational numbers, this is meaningless. So that in general, if you see this expression, you need to simplify it by multiply root 5 over root 5. Why? Because I know when I multiply root 5 to the denominator, root 5 times root 5 will become 5. That means I can change the denominator by integer. So simplify is root 5 over 5. This is the final answer. This process is also called rationalizations. Example 1.1b, you can also use the similar idea. For example, I need to do the rationalizations. I can multiply root 14 over root 14. Then the denominator becomes 14 and the numerator is 21 times root 14. Remember, you need to do the simplification. Divide by 7. So this is 2 and this is 3. So the final answer is 3 root 14 over 2. How about example 1.2? How can we do the rationalization if the denominator is sum of two terms? What can we do? The correct method is that we can make good use of one of the identity. A squared minus b squared is equal to a plus b times a minus b. Make good use of it. How? Because I want to take square of this term in order to change root 3 to 3. So you can regard root 3 plus 1 just like a plus b. I need to multiply a minus b in order to use the identity to take square for the first term. So I want to demonstrate it. Time, make good use of it. Remember, it's not time root 3 plus 1, because root 3 plus 1 times root 3 plus 1, we cannot use this identity. We can use another identity, but the denominator still have the third form. So time root 3 minus 1. Not very difficult to understand. Root 3 minus 1. Root 3 minus 1. Then the denominator become a squared minus b squared. That means root 3 squared. That means 3 minus 1. So root 3 minus 1. Simplify it. This is 2 root 3 minus 1. This is the final answer. Example 1.2b. What can we do? Same idea. Because this is root 5 minus root 2. So, just like this term, I can time root 5 plus root 2. So that we can take square these two terms separately and then cancel the square root. So time root 5 plus root 2. Root 5 plus root 2. The denominator is root 5 squared, so 5 minus root 2 squared, 2. So 3 times root 5 plus root 2. So cancel it out because 5 minus 2 is equal to 3. So the final answer is root 5 plus root 2. For exercise 1, remember you need to pause the video and then check the answer after you finish. You may check your answer. Question 1a, time root 15 over root 15. So the denominator become a integer. And then this is 15. 5 times root 15. Do the simplification. You can get the final answer root 15 over 3. How about the second one? Okay, make good use of the identity, time 2 plus root 7. 2 plus root 7. And then simplify it, not very difficult. This is your final answer. Part C, same idea. This is a plus b. I try to multiply a minus b in order to take square of these two terms separately by using the identity. So this is 7 minus a squared minus b squared. So remember, you need to simplify these terms carefully. I will do it step by step. This is 2 root 2 all square. So 2 squared is 4, root 2 squared is 2, so 4 times 2. And then this is root 7 minus 2 root 2. And so the denominator is equal to -1. How can I simplify it? I can multiply -1 to the denominator and numerator, so that this -1 times -1 is become 1, and then times -1 to the numerator. The final answer like this. Page 3. The last example I want to demonstrate. Example 1.3. In M2, in general, we do not need to simplify the previous example, but we need to know how to simplify the term like this, but the idea is similar. So, how to simplify this term? Can you recognize this form as a minus b, and then a with square, and then b also with the radical sign, so that I need to use the identity times the positive 1, so square root of 2x plus 3 minus square root of x plus minus 1, so 2x plus 3 take square root minus square root of x minus 1. For the denominator, which is equal to a minus b times a plus, this is positive sign. So for the denominator, I know a minus b times a plus b, so which is equal to a squared minus b squared. Square root and then square, so 2x minus plus 3. Remember, if I were you, I will add bracket here because I need to do it carefully. Normally, we'll have some common mistake for simplify this term because this is negative sign of the b square. So you need to add bracket here. How about the denominator? Maybe you can copy it down first. 2x plus 8 times, and then don't expand it, because you useless when you expand these two terms because you do not know how to simplify them. And then simplify the denominator. 2x minus x, so which is equal to x, and then 3 plus 1 is equal to 4. Can you see I can take out 2 for the first term? I mean this term, 2x plus 8, I can take out 2, and then remain x plus 4. Why I need to take it out? Because I can see the common factor for the denominator and numerator. So after taking it out, you can cancel it. So the final answer is 2 times root 2x plus 3 plus square root of x minus 1. And try to finish for exercise 2, and then the last example I will discuss with you during the lesson.